Arabic NLP Toolkit project. We will give, as Ashraf said, I will give a brief overview about the ATKS. Then Islam will go for more details, and we will have some time for questions. Okay, let's start. This is the agenda. Let's go ahead. Advanced Technology Lab in Cairo. This is our team. We are an lab, part of the Microsoft Research Organization, and we are one of the MSR labs around the world. We have three main teams in the lab. The first is the NLP team, Natural Language Processing team, and this is the team that developing and building the components we are willing to talk about them today. The second team is the computer vision, and this is a group of RSDs and the researchers that mainly working in the multimedia field, especially in image processing, scene detection, and object detection, and so on. And the last big team is the Bing Cairo. This is part of the Bing global team, and the main responsibility of this team is to enhance and add features to the Bing search engine in the Arabic market. Okay, let's just start with our team, the NLP Group. As a group, we have a short-term mission or goal to enhance the Arabic-specific features across different Microsoft products like search, machine translation, proofreading in Office, and enabling non-existing feature like Arabic speech recognition. This is for the short term. For the long term, our big goal is to offer the most comprehensive and best Arabic NLP functionality through Windows, through the cloud, and scale this functionality even to non-Arabic, to other languages rather than Arabic. This is the first. The second, and this is the relevant to our talk today, is to enable our partners and developers build solutions and apps on top of our technology and the components to target market needs. And this goal is mostly satisfied through the ATKS APIs and components that we will talk about today. Okay, when talking about processing Arabic language, we have to be very well aware that in Arabic has some unique complexities that makes it special. For example, for the omitted diacritics, this is the small shifts over the characters. This like the vowels in the English language, and the overwhelming majority of people, of the Arabic people, is used to write without the diacritics, and this adds a layer of hardness to process the text. Another example is the high word error rate. For example, on a study we have made before, over around 1,000 news articles, we have found that in around 6% of these news articles have mistakes. And imagine that if these articles have been revised and reviewed by professional editors at these news agencies, so the percent is expected to be much higher in free text Arabic on the web. Another example is long sentences. When the average sentence in the Arabic text is about 21 words, this can tell you how it's hard to process and to tag these long sentences. In addition to these challenges related to the Arabic as a language, the resources available to help people are limited in terms of training data components or linguistic references. And if we are willing to tackle or to have a high accuracy components, we have to tackle these issues genuinely. And this is the main reason why most of the Arabic processors existing in the industry today have an average or moderate accuracies. And our goal is to have a very high accuracy, and this also adds a layer of difficulty to processing Arabic text. Okay, now this diagram, this block diagram gives you a high-level overview of the Arabic NLP architecture. The green blocks are the components we are done with, and the yellow ones are the components currently in development. I will give a brief description about each component, and then Islam will give you more details. First, we have started with the Transliterator component because the component had no dependency on other components, and the outcome then was the desktop version of Marin. If you or most of you know Marin, the desktop application enable you to transliterate text from Arabic from Latin characters to Arabic words. Then we have started to build our morphological analyzer that's called SARF. Morphological analyzer is the component that gives you all possible analyses for a given Arabic word, and it is a critical component for all other NLP components. So it was the first to start to build. Using the same framework, we are started to process the colloquial text, especially for the Egyptian dialect. Then we have built the autocorrector that automatically detect and correct mistakes in Arabic that we are calling it common Arabic mistakes. Common Arabic mistakes comes from wrong writing of initial hamza or ta marbuta and ya in the Arabic words, and about 95% of the Arabic mistakes are common Arabic mistakes. So the autocorrector gives you the automatic correction for this. And using the same framework, we have built a full-fledged and full-featured speller component that handles other types of mistakes and gives the user multiple suggestions to pick from. Exactly the same scenario like the proofreading and spelling checking for the English language and others. The autocorrector detects replies on morphological analyzer to detect the errors and validate outcomes before offering it to the user. The next component we have built is the named entity recognizer. Named entities, categories. Entity recognizer components is automatically identify and classify named entities in Arabic. And named entities in Arabic has three main categories. That's names of persons, locations, and organizations. And the autocorrector depends on this component to bypass named entities from corrector, because named entities is not necessary to be wrong words, but it has to be skipped when detecting erroneous words. The next component is the POS tagger. This is the component that automatically tags or making the part of speech tagging for a given word. And part of speech means that if this word, for example, this word is a verb or noun and so on, and this component, as shown in the diagram, it depends on the autocorrector to automatically correct the input text, and depends on the named entity to pre-tag named entities, and depends on the morphological analyzer also. The last component that we are finished is the automatic diacritizer. This component is automatically restores the missing vowels, the missing diacritics on the Arabic text, and it relies on the parser component and the POS tagger. Parser is a component that's currently in development, and this component depends on the autocorrector to correct the input text on the NAR and the POS tagger. Now I will talk about the tagging system, the building block at the bottom of the graph. This is the system we have developed to tag all our corpus, and why the components are being developed, it being gradually integrated in this tagged system. We have now about 4 million words in this tagging system, and by the time the tagging system grows, it improves the speed of labeling and tagging, like using named entity recognizer, using the corrector to correct the text and tokens in the corpus. Now I am almost done. Islam will go through this block diagram in some details, give you a brief description about the features, available APIs of the ATKS, and make sure if you have any questions, don't hesitate to ask us, and feel free to give us also questions over link in instant message. Okay, Islam, go ahead.
Hello, I am Islam Kamal, a dev in the Arabic NLP team in ETL Cairo, and I'm going to give some details about the different NLP services that can be found in the Arabic NLP Toolkit. I'm going to start with the transliteration, and let us first define what's transliteration. It's basically the conversion of text from one alphabet or script to another alphabet or script of a different language, keeping the same pronunciation. So we use this for named entity translation. We use it for named entity translations, like when I say Michael or Ahmed, it is written in different letters in Arabic or English, but it is pronounced the same or nearly the same. It also solves for us a common problem in Arabic and some other languages, that we find many pieces of text written in websites and even on TV that are Arabic words and written on Romanized letters, and using transliteration we can convert these letters back to the native Arabic script. Another very useful contribution for transliteration, for example, is in the machine translation system. In the example here, we can see that the word Michigan, it is not known by the machine translation system, and so it is not translated. Its translation is not correct, and it affects the whole system badly, as we can see in this sentence. However, with the presence of a good transliteration system, we can correctly translate the word Michigan, and also have a positive effect on the overall performance of the system. Well, when we are going to use the transliterator from the Arabic NLP Toolkit, we will find two main APIs to call. One of them is to transliterate text, given the input text and the pair of language to convert from to. We have Arabic to English, English to Arabic, English to Farsi, and other pairs. The other API is to generate multiple candidates for one input word and having different candidates for it. Here, example of using the different APIs. We can use it to transliterate a sentence or a phrase, like here, ازيك عامل ايه, and also for named entities in both direction, Arabic to English and English to Arabic. The last example is about generating multiple candidates, and this has a special usefulness in named entity normalization and search. Well, as we have said before, translation has a very positive contribution in machine translation, and is the main bone of another important application. That's the named entity normalization. As we can see in banks and the huge organizations, they have a huge database of names, and the search in this database is difficult because people write names in different formats. However, if we have a transliterator to use, we can normalize the way these named entities are written, and this enhances our search accuracy. Another application for the transliteration is the input method extensions, which allows us to write different languages using the English keyboard. And a very common application of this is Microsoft Marin. I assume some of you are familiar with it. You can download it from getmarin.com and play with it. Okay. I'm done with the translation, and I'm going to move to the morphological analyzer. If you have questions, please ask through the IM. Before going into the details of SARF, I want first to explain the Arabic word structure in general. So I will pick this word as an example, وَسَيُحَاكِمُونَهُمْ, and we can see that it consists of two prefixes, where the end conjunction, and the scene here is a future article, plus a subject as a suffix, and also an object as another suffix. its stem is يحاكم, has a root حكم and a morphological pattern. Its part of speech is a verb. So what we can see here is that this word is a complete sentence. It has a verb, a subject, an object, and even a conjunction. It also have some morphosyntactic feature like being in the present tense, plural, and third person. So we are going to use SARF from the Arabic NLP Toolkit. It will basically provide us all possible morphological analyses for a given input Arabic word. Further, the analysis is composed of the word diacritized and the prefixes, suffixes, stem, part of speech, morphological pattern, root, and morphosyntactic features. There are other features that we can use from SARF, like validating Arabic words. So if I input a word to SARF and it is analyzed, then it is a correct Arabic word, and if it has no analysis, then it is not a valid Arabic word. We can also synthesize a word from its analysis, and we can use this to apply different prefixes and suffixes on a stem we have. Other features are generation of derivatives and inflections of a given word, and the example we'll see later will highlight these features better. Another important feature is that if you presented a partially diacritized word to SARF, SARF will be intelligent enough to filter out the morphological analyses to cope with the initial diacritization. Here's a typical example of applying a SARF on a word al-hakam or al-hikam. It has different analyses, as we can see. If we take a look at analysis 1, for example, the word is diacritized. It says to us that it has a prefix al, the stem hop, no suffixes, its part of speech is masdar, and it has other features like being muscular, singular, and defined by there. And as long as we have a big text corpus, we were able to learn the probability of this analysis appearing in the text, and we can see here that it is 73%. The other two analyses are different in their part of speech and the morphosyntactic feature, and we can see that they have lower probabilities in the Arabic text. Generation of derivatives and inflection is presented here, and we can say that derivatives are the words that share the same root with the input word, while inflections share the same stem, so they are different only in prefixes and suffixes. Well, how we can make use of SARF in application? For example, we have used it for autocorrection and spell checking, as we will talk later, and also in part of speech tagging and diacritization. Generation of inflections and derivatives is very important for search to expand the query or even at indexing time. It can also be used in machine translation and different applications. Now I am done with SARF, and we'll move to the autocorrector and spell checking components. And if you have questions, we can answer them. Okay, Tamer gave us a brief note about this investigation. It was held